All right, so I believe you just finished practice quiz 5.2. Hopefully that was a helpful exercise for you. Now that we're midway through the period, I want to have you guys do a couple of, let's call them warm-up questions, and then I'll go into a brief vocabulary review and give you your final homework assignment. As a reminder, tomorrow is your Chapter 5 test, and Thursday, your 9 weeks review packet is due. So this is a really text-heavy warm-up. I'm not sure you're going to be able to see it from where you're sitting, so sorry to do this to you, but I'm just going to read it. An experiment was conducted where you flew paper airplanes after modifying wing width and wing length. There were 4 different models of airplane. One design consideration was the choice between flying each plane 4 times or making 4 copies of each model, each of which is flown once. Which of the following is not correct? So we have 4 different models. We're considering either flying each model 4 times or making 4 copies of each model, each of which is flown once. And it says, which of the following is not correct? A, flying multiple copies of each model, that is separate planes of each model, could give you information on variability in flight due to fabrication effects, that is how you made the plane. B, flying a single copy of each model 4 times could give information on variability in flight due to changes in initial launch conditions. C, the differences in flight length among the different models give information on the effects of the design factors, wing width and wing length. D, the response variable is flight length. The explanatory variables are wing width and wing length. E, the net effect, whether flying each plane 4 times or flying 4 copies of each model once, would be the same. Please pause the video for 2 or 3 minutes to allow students to answer this question. Okay, so the key thing here, guys, was noticing is this is a which of the following is not correct question, which means, that 4 of these answer choices should be viable and 1 should not, and that one that's not is going to be our answer. And so just to kind of save you the suspense, the answer to this is E. The net effect would be the same because it wouldn't. The other 4 are correct. If I do multiple copies of each model, that tells me something about how different copies of the model behave differently. Meaning if I make the same model plane twice, it's not going to be exactly the same. So it says give you information on variability due to fabrication effects. That makes sense. A sounds good to me. B says that flying a single copy of each model 4 times could give information on variability in flight due to changes in initial launch conditions. Again, that makes sense. It's the same exact plane. What else could be different? Well, the way I launch it could be different, okay? Or maybe something like the wind or the air conditioning or something like that about the way that it's launched. So B makes sense to me. C, the differences in flight length among the different models give information on the effects of the design factors, wing width and wing length. Sure, okay, the differences in length tell me about the effect of the factors that we're testing, which are wing width and wing length. So C and D are really related. My response variable here, what I'm measuring at the end, is how long the planes fly. And the explanatory variable, what I'm using to explain what happens, are the wing width and the wing length. So the answer here should be E. Here's another question. A committee on community relations in a college town plans to survey local businesses about the importance of students as customers. From telephone book listings, the committee chooses 150 businesses at random. Of these, 73 return the questionnaire. The population for this study is it all businesses in the college town, all businesses, the 150 businesses that were chosen, the 73 that returned the questionnaire, or the committee on community relations? Please pause the video for 2 to 3 minutes to allow students to answer this question. Okay, I kind of gave it away here, but the key word here is population. Remember, the sample is who I'm actually able to examine. I would say that the sample is the 73 that returned the questionnaire. The population is who I'm trying to generalize my conclusions to. Who am I trying to draw conclusions about? Well, local businesses, okay? So it's not the 150 that were chosen. It's not the 73 that participated. Sorry, but it's certainly not the committee. And so it's either businesses or all businesses in this college town. Those 150 were chosen out of all businesses in this college town. So I would say the answer here is A. All right, let's do a quick vocabulary review, and then I'm going to give you one final homework assignment for this chapter. We need to know the difference between an observational study and an experiment. And the key difference is that in an experiment, we are imposing a treatment. In an observational study, we are not. So did I examine the difference between patients who are already taking Advil and patients who are already taking Motrin? Or did I assign some patients to take, I already forgot what two things I said, but did I assign an actual treatment? If so, then it's an experiment. If not, then we're dealing with an observational study. Our second warm-up question dealt with the difference between a population and a sample. The population is the entire group that I'm trying to extend my conclusion to, whereas the sample is the one that I actually examine in order to try to draw that conclusion. If I actually am able to get information from the entire population, that's called a census. So if I'm able to survey the entire population, that is called a census. I have a few different sampling techniques. Voluntary response is when people self-select to be part of my sample. Convenience sampling is exactly what it sounds like. I choose the people who are easy to reach. Bias, that's a tricky term, but what that means is that certain outcomes are systematically favored because of something in the design or in the environment or something like that. So certain outcomes are systematically favored. I think I've told you this already, but I have a big pet peeve when it comes to the word bias. Students have a tendency to just throw that word out there thinking it explains everything. Oh, this study is bad because bias. Man, I got that question right. No, guys, you have to explain what bias means. What's the source of the bias? And in what way is our conclusion going to be affected? Okay. The study about people's favorite TV show is certain to be biased because the researchers chose a convenient sample at a nursing home. So this is going to make it seem like people's favorite TV show is The Price is Right, when really that's a TV show that caters more to the population at this nursing home. Something like that. Simple random sample is a much better way of choosing a sample, and we know by now that if you're asked to describe how to take a random sample, you are going to put names in a hat, and you are going to shake that hat. We need to know how to use a random digit table, so if that's something that's tricky for you, please go back and watch that video. Probability sample is any sample that uses probability to select. So that could be a simple random sample, a stratified random sample, or a cluster sample. Okay? Your sampling frame is the list that you make before you put names in a hat, for example. Stratified random sample and cluster sample. I hope you remember the analogy here. It was about trail mix. Stratified random sample is make your own trail mix. You take a sample of raisins and a sample of peanuts and a big old sample of M&Ms, and you mix them together yourself, and that is your sample. Whereas a cluster sample is store-bought trail mix. They're pre-mixed, and you pick a few bags. Okay, so did I choose a few previously mixed groups? If so, that's a cluster sample. Or did I choose some individuals from each of a few homogeneous groups? Then that's a stratified random sample. Under coverage and non-response. Under coverage means that there are individuals who are left out of the chance of being selected. So remember, if I am calling landlines from, some kind of yellow pages or something like that, then people whose numbers are unlisted are subject to undercoverage because there's no chance I'm going to reach them because their number is unlisted, for example. Non-response means people choose not to participate. So if I'm making phone calls and somebody hangs up on me, that would be an example of non-response. Or if somebody doesn't return their survey, that's non-response. Response bias is when people give me inaccurate responses. This can be because they don't remember. This can be because they don't want to own up to whatever their real answer is. Okay, if I'm doing a survey about how much fast food people eat and somebody eats fast food 15 times per week, they're probably going to not give me an accurate response because maybe they feel a little bit embarrassed by that or something. The wording of the question can lead to bias because questions can be worded in a confusing or overly technical manner. All right, moving into more experimental type vocabulary. Remember, experimental units, that is the smallest unit that I can apply a treatment to. So that may be a person. By the way, if they are people, they are usually called subjects. It may be a tree. It may be a plot of land. It may be a bunny rabbit. It's just whatever the smallest unit I apply a treatment to. Treatments, factors, and levels. There was a really good video that explained the difference between those three. Go back and watch that one if you need to, okay? It's still up. I think we're probably clear on the placebo effect. Students usually have a pretty good understanding of that. The three basic principles of experimental design, those are control, randomization, and replication. Control means I keep everything else the same except for the treatment, okay? So if my treatment is using a certain type of fertilizer on plants, then everything else needs to be the same. They need to get the same sunlight. They need to get the same amount of water. They need to be preferably the same type of plant. Everything needs to be the same except the treatment that I am applying. Randomization means that I randomly assign which experimental units go into which treatment group. Usually that means names or numbers in a hat. And replication, remember, this is the one that doesn't mean what you think it means. A lot of students think it means writing up your results really well so somebody else can repeat them or doing it all over again. No. Replication means that I have more than one experimental unit per treatment group. Okay, if I only have one experimental unit per treatment, then I don't know if differences in the response are because of the treatment or because of variability among experimental units. So that means I need lots of bunnies receiving each treatment so that differences in individual bunnies don't make a difference. A statistically significant result means one that is unlikely to have occurred by chance. I see a big enough difference in treatment groups that I don't think it happened just by chance. A completely randomized design means names in a hat. It's kind of like an SRS. I completely randomly assign who goes into which treatment group. A block design is kind of like a stratified design. It's kind of like stratified random sampling. They're not the same thing. Stratified random sample is a way that I choose a sample, whereas a block design is a way that I assign to treatments in an experiment. Stratified is for sampling, block design is for experimentation. But the process I go through is similar. I split my experimental units up based on certain traits, and then within each group, within each block, they get assigned to the different treatments. A specific way to do that is with matched pairs. That's like a twin study. Okay, I have two people that are paired together very closely, and then I randomly assign each of them to one of two groups. In a matched pairs design, I can only have two treatments. We're usually pretty okay with double blind. Double blind means neither the person receiving the treatment nor the person administering the treatment knows which treatment that the experimental units are getting. And then lack of realism, we just talked about recently. What that means is sometimes in an experimental condition, things don't play out the way they do in the real world. And so the conclusions we draw in a lab don't necessarily extend to the real world. I know that's a lot of vocabulary, but you can go back and rewatch every single video if you need to. Make yourself some flashcards. Make sure you understand that vocabulary. Here is homework number 5. This is the final assignment. It is due tomorrow for your Chapter 5 test.